name's Joshua Kraitberg. I'm from Wind River, and I work on the StarlingX project. I'll be talking about edge orchestration and managing critical workloads at scale, specifically for platform upgrades and Kubernetes upgrades. Some background: I'm a member of the technical staff. Been on the project for about 3 years now. I've worked on things like backup and restore, platform upgrades, and some other virtualization initiatives. Just to go over what's going to happen here is just going to talk about mostly just platform upgrades, Kubernetes upgrades, and overcommitment of workloads. So StarlingX runs in many kinds of environments. They run mission-critical workloads, and they run oftentimes in remote regions and areas where there's not many skilled operators available. And so because of that, you end up in scenarios where there's too many workloads and not enough servers. And so we have solutions in StarlingX for that. The main ones are HA and resource limits and quality of service. But I'm also going to be proposing some forward-looking solutions that aren't available right now, but based on feedback and interest, could become available. And so that's going to talk about per workload, quality of service, and ephemeral nodes for automatic scaling of systems. And so to give some background on StarlingX, it's a complete cloud infrastructure software stack. So we've got Kubernetes, OpenStack, and SEP all in one system. And a system is comprised of multiple nodes. It could be one node, it could be two, or it could be up to 100 right now. And so we also have real-time low latency support, which is critical in several fields, for example, telecom and medical. We also have something called distributed cloud support. It's a complete infrastructure for having private clouds in geographically distinct locations. So you're going to have one system called the system controller, and it's going to be managing up to 1,000 systems called subclouds. And through that system controller, you're going to have a centralized management interface for orchestrating and manipulating those subclouds in parallel. And so that subcloud is really just an independent, localized edge system. And it's during normal operation, it's going to be autonomous from the system controller. So you can lose that central management plane, and there will be no impact to the clients on the subcloud. And so for us, orchestration is the process of automating platform upgrades and Kubernetes upgrades. There's some other orchestration actions, but I'm not going to cover them here. What you end up with, in effect, is reduced operator oversight, improved operational efficiency. And because of this, you have the capability to schedule your upgrades and your orchestration during specific windows. A lot of users have peak periods where they can't handle any sort of disruption. So being able to schedule that in and get it exactly in the window is very important. And of course, there is a graceful rollback on failure. Things go wrong, so you need to get back to that healthy state as quickly as possible. Internally, what these upgrades look like is they essentially run in two phases. First, you have the build phase, which does an overall check on the system. And then it looks at the state of the system and it ensures that you are in the correct state to be undergoing this orchestration operation. And at the very end, it builds the apply phase. And so these are statically built phases. And so the apply phase will just undergo the manual operations that you could undertake as a user if you really wanted to. But basically, it's going to upgrade the control plane, and then the worker plane, and then the storage plane, and then it'll do any sort of finalization operations. And then afterwards, you're going to start the next part of the upgrade, which is the Kubernetes orchestration, which is in essence the same thing, just different steps. And these two are always going to be together. You're always going to be upgrading the platform and then Kubernetes. You wouldn't be just upgrading Kubernetes. They're sort of linked right now because of how we push patches and upgrades out. And so during these orchestration events, nodes are going to be taken down, depending on if that's required for the specific upgrade. And so during this time, you're going to have workloads that are being migrated between the nodes. And so for OpenStack, that means live migration or VM shutdown. In a lot of cases, VM shutdown is not acceptable. You need those workloads to remain up. And then for Kubernetes, it is done by doing cordons and drains so that the pods are rescheduled to other nodes that are not being upgraded at the same time. And so during these orchestrations, we can upgrade nodes in parallel. Right now it's up to 10 nodes in parallel. And so a lot of users don't plan to have 10 nodes down at one time, which really causes problems for the overcommitment of resources. Because if they want those workloads to be migrated and they're taking down 10 nodes at a time, it's just not going to work out for them. So we need to manage what's going on for them to prevent them from shooting themselves in the foot. And so there's a lot of reasons overcommitment happens. For us, the big ones are access to remote locations. They're trying to reduce server costs. If you can take one server out of each system and you've got 10,000 or 100,000 sites, that's a massive win, and it looks incredible on a spreadsheet, and I guarantee you the executives are going to want that. And of course, workloads compete for resources. A lot of the workloads are mission critical. In telecom or 5G, they're going to tell you that these things need to stay up. If something goes down, the penalties are massive, or there's the chance of people being hurt. And then, of course, there's time constraints. We've all probably been there. Something needs to go up, and so sometimes you just can't wait 6 months for a server procurement to happen. So you just jam it in, and that's what happens. To paint a little picture of maybe something you might see in the field, you have an edge site located about 500 kilometers from the nearest city. For one reason or another, a node has suffered a critical failure during the orchestration, and now the other nodes that are still available are going to be overloaded, so that could lead to cascading failures. What you'll probably see first is out of memory errors, and then you'll start to see stalling, and eventually that could lead to kernel panics and failures, and that's going to complicate the rollback operation. Because once you get into this very unstable state, you're going to have a lot of trouble. And that's when you have to send someone in manually to do some manual operations. And this is when the costs really start to rack up. Because in a location like this, you're going to have to fly them out. They're going to need specialized equipment. And after all this is done, you're going to get hit with, as the software provider, you could get hit with SLA violations. And as the operator of this server, you could get hit with regulatory actions, and that'll trickle down to your company as well. And at the end of the day, it's going to be the developer's problem. No matter what the cause was, it's all going to circle back to the developers. And so the solution zero is not exactly a solution for the platform. It's just make your workloads highly available. This shifts responsibility from the platform to the users. So there's going to probably be some pushback, but it really is the most flexible and robust solution, having that high availability on the actual application. But you're not limited to doing it on the application. You can have domain-specific solutions as well. Like in telecom, you're going to have overlapping cell towers, so if one tower goes down, the client device, like your cell phone, will just switch over, and it's just a seamless experience. And this can extend even farther into something like piggybacking, where they use competitor infrastructure to shift load, which is, they'll tell you that's not a solution. because of cost, but for us as a consumer, it's a solution. So what we have in StarlingX right now is alarms and resource constraints. These are configurable. So if you reach a certain threshold in terms of CPU, memory, or storage, you're going to get an alarm on the system, and that's going to prevent you from taking certain actions and operations. So there's two kinds. There's warnings and there's a management affecting alarms. So you can set that. By default, they are at 80% for warnings and 90% for management affecting. And so the problem here, though, is that these alarms are per node, not per system. So you can get yourself into hot water if you don't configure these thresholds correctly. Because if you leave them as defaults and you have, say, 10 nodes, and you're right at the limit, you're going to be 90% capacity on each node. So you really can only tolerate one node of downtime. And if you want to do a fast upgrade and do multiple nodes in parallel, you're gonna have issues. Right. And so after that, of course, OpenStack and Kubernetes both provide their own quality of service mechanics. The OpenStack has quality of service policies on the actual services, so Neutron or not Nova, I think, that's a bit experimental. But Cinder have their own limits, you could say. And then, of course, Kubernetes has limit requests and limits and cluster limits and whatnot. So you would control it like that. Something that we don't have, that we would be doing based on the correct feedback, is policy-driven orchestration, where you actually, as the user or as the app owner, would add metadata to your workload to sort of inform the orchestration operator what kind of actions it can take on that workload. Can it shut it down? Can it migrate it? Is it interruptible? When is it interruptible? And things like that. And based on that, the orchestration could be scheduled for a specific time automatically, and that would really offload a lot of oversight. So you would just say, hey, I'm ready for my major upgrade or minor upgrade, and you would give it a target release. And since it knows all this metadata already, it would just pick a time and it would go do it. And ideally, you would get an alert or something when that's done. Perhaps in Grafana, that could be like an annotation, or you could get an alert from Alert Manager. But of course, this is just conceptual. And then solution 3A is something also that is forward-looking. Right now, we have something called geo-redundancy, and it's a mechanic used in distributed cloud for disaster recovery. So if you have two distributed cloud sites that are distinct but geographically close, you can actually take subclouds, which are just edge systems, and you can move them to a different distributed cloud to replace failed systems. So instead of replacing individual subclouds, we could take nodes and just move them to systems to sort of augment their capacity during periods when you need extra capacity, like during orchestration or just for general scaling. And then to extend onto that, there is going to be cloud scaling. So it's the same kind of idea, except instead of using physical nodes that are in close proximity, you can just spin up a cloud VM. So what we have right now is something called factory enrollment. So you take an existing production release or GA ISO, and you can modify that and insert data, scripts, startup scripts, whatever. And you can create a cloud image that you can upload to a cloud provider. And so that'll auto-install itself and automatically have that node join an existing system. And so because it's in the cloud, you'll probably need some sort of VPN integration to make sure it connects. And if you're going to be using a public cloud provider, this might not be an option. There's going to be laws, regulations, or internal policies probably preventing this, especially if you're dealing with private data. Right. And so, because those were just conceptual and forward-looking in nature, what we really want to hear from the community is there any interest for those new features? Are they wanted? And if they're not here, if there's something missing from here, would that work for you as well? So we're just interested in getting some community feedback. All right. Yeah, questions?